Hello, everyone. Welcome to Basecamp 12 session 2. Today, we'll talk about Cairo smart contract. But before we start coding, David would like to do a short recap on session 1. David?
Yes, hello. So just to refresh your mind what we covered session 1. In session 1, it was a lot of theory, a bunch of slides. We covered like why Cairo is a programming language, why is Starknet as another ZK rollup on top of Ethereum. We also talked about smart wallets and how they actually are implemented, the differences between the smart wallet and an externally owned account that you find on Ethereum. I show you how to actually install the wallet or one of the wallets on your phone, help you to claim a SPOC, which is like a POAP for just attending session 1. Then share a few insights about the upcoming integration with Bitcoin that Starknet and Starkware is working on. I show you how to do the whole setup of your dev environment in your computer using Docker image and the extension dev containers. And finally, there was a short quiz of 5 questions. So just to put you into context before we go into session 2 with Charlotte. So yeah.
Perfect. Thank you, David. And before we start the session, don't forget, if you haven't joined the Discord server, please join the Discord server because we put announcements there. And we also have a resource page, like with all the tools set up, that the things you need to know, and also some useful links that we provide. So now, Charlotte, hand over to you. Do you want to do a short introduction to introduce yourself?
Yep. Hello, everyone. My name is Charlotte. I've been working in the Starknet ecosystem for a while. I first contributed a lot to OnlyDus, then joined Giza as a ZK/ML engineer, been working in Nethermind for a while, and then contributed as a ZK freelancer now for some projects also in the ecosystem. So yeah, I am based in Thailand and I speak French and English. So I will give today the session on Cairo smart contracts. So there's going to be like 4 main sessions and then 1 bonus session. Today is the second one, so it's on smart contracts. And yeah, we will learn a bit how to code in Cairo and really focus on the smart contract application. So Cairo is a general purpose language, but today we will really dive into smart contracts applications of Cairo, which is the main one. And we will start right away with a counter contract example. So what we are going to do today is I'm going to demonstrate how to make a smart contract in Cairo. And we will make a counter example, so like a very basic smart contract where you will have a counter that you can increment, and so the value of the counter will be stored on chain, and you will have to make transactions to increase the counter or reset the counter. So we will define everything that needs to be implemented in the smart contract, and also as I go through the example, I will teach you everything that you need to understand to understand fully the example. So I will not give a theoretical lesson. I will teach you every item. So if you don't know anything about smart contracts, you can follow and you can understand everything. And it's going to be very self-contained, so don't be afraid about it. Also, the code that I will be coding today will not be pushed, and it's going to actually be an homework for you. So I really suggest that you code along, so you actually already do your homework and you don't have to do it again. But don't worry, there's going to be a recording of the session. So if you need to rewatch it later, it's also a possibility. Just the code will not be pushed. So I will actually go back. I will resume where David left out last time. So last time David made the setup. So the setup is actually quite easy. And once the setup is done, you have this very, like, this is the state of what is created after the setup. So it's basically a very basic example of a contract here. And we will start from that and start from scratch and do a counter contract. So I will start by creating the contracts. Now I'm going in this. So in a Cairo program, you have this lib file in which you have to define everything. So here I define my counter contract here. I'm gonna delete the test. So the test is gonna be for another session, I think. And yeah, so for now, I'm just gonna delete them so that we don't have any compiling error because of the test. Okay. So, okay, so now we need to make a counter contract. So there's gonna be a lot of different things that needs to be done. So first, we will need to make sure we have the right syntax for building a contract, the right elements, and then the right functions to actually do the counter. So have the amounts on chain, and then the ability to interact with that amount and the ability to change it. So let's dive into it. So first, I will actually start by doing the most basic so I'm gonna make the most basic possible contract. So in Cairo, to have a smart contract, you need to have this annotation, and then it's a module. The name is counter, and then I need a storage. Is So here is actually a correct smart contract in Cairo. So so to be convinced by this, I'm gonna go to okay, so basically here we have the most basic contracts in Cairo. It has the annotation contract, so the compiler know that it's a contract. Then it's a module, it has a name. The name can be anything, like I decided to make counter, so it's makes sense. Then this is the storage, so it's what's gonna be stored on chain. It's a struct, which is a data type in Cairo, and the name has to be storage, and the annotation needs to be storage. It can be empty, and that's actually a smart contract. That's valid. It's useless, but it's valid. So for our counter, we will create an amount in the storage. So here I'm going to use the type U32. So the amount will be a number that will be stored on chain. Okay. And so now we will continue. So we need many more things to make it to make the full counter smart contract. But what we are going to do now is the constructor. So the constructor is a function that's going to run only once. And that's actually going to run when you deploy it, and it's going to initialize all the, like, it's going to set the initial states on chain. So it's a function, it's called constructor. It's going to take as arguments a reference of the contract states, because it's going to modify the contract states. So it has to take a reference of it so that it can modify it. It's actually also going to take an initial value that has to be U32 to make sense. It doesn't have to take an initial value, like you could decide that it's set up as 0 and like don't yeah, that it's not a choice, but yeah, I'm gonna do it like this. Okay, so now
Ayub is saying that you're missing the S in constructor in the attribute at the end. Constructors.
yeah,
Constructor, yeah.
Yeah. Thank you. Okay, so now the constructor will access the amounts and maybe bit counter. Yeah.
Charlotte, there's a
Right.
question from you from
Yes.
Rahman. What is a struct?
So a structure is a data type in Cairo that can be a bit custom. So it's very useful, for example, if you need a data type to always have the same structure. So you define the structure once and then you can reuse it. So for example, if you want to create like a struct that would be a person, you can have like a field with the age, a field with the name, and a field like with, I don't know, other information. And so it's like a common programming concept that is very useful to always have similar data. And here it's just, it's very useful to make this for the storage. Even if there's only going to be one storage for the contract, it's following the same principle. Like you can custom your own structure and access it easily. I hope that answered your question. So now the constructor will have to write in the storage. So show value. So now we have an error because we need to make sure we import the ability to write in the contract stage. So we will use Starknet right. So this pointer, is it in storage? Yes, storage. Storage pointer write access. Okay. So now it's working. So basically, to be able to write in the storage, you need to import here. So here with this, I'm importing some function and some functionality that wouldn't exist in the normal context. So in the normal context of Cairo, there is not a lot that exists. Maybe in other computer language, you are used to having a lot of function that can be used in the like standard context. But in Cairo, you actually usually have to import a lot of functionality and function, which makes sense because it's like more optimized to restrict what can be used at any time and only import what is needed. So here, the possibility of writing in the storage has to be imported. So with this, with this, we actually import the function. Okay. So we can build the contract, but it's not like we can already tell that there is no error. So this is again valid. Okay, so now we have a very simple contract that has a storage. When we deploy it, it's gonna create a storage with the value of counter that has this initial value. Okay, so now we're gonna actually start implementing the logic of the contract. So when you want to create the logic of the contract, there is a separation between the function that are used internally in your logic, in your code, and that are going to be possible to use externally. So to interact with the contract and what the user of the contract will be able to do. So now we will only focus on that. So the function that can be externally used and that can be used by your by the user of your contract. So they need to follow a specific syntax and they need to implement an interface. So now we're gonna make an interface. So it's also a very classic good practice coding principle to have an interface, so that you know what function exists, what function needs to be implemented, and also you can define the specification of the function in the interface and have a very easy like overview of the blueprint of the smart contract, like what the smart contract is about. So is it? No, it's a trait. Okay, so the interface is actually a trait. So a trait is a way in Cairo to implement something in a generic way. So you don't implement it for a specific type, you just implement it, but you keep the type unbound, and so you can implement it later with a specific type. So it allows to be reused or to have multiple implementation with different data types, because Cairo is strongly typed, and the type cannot necessarily like be interchanged. It's very useful to have this generic implementation and then implementing it for the type that you need to make sure everything works. And yeah, so here I will implement it on contract state. I added a T to know that this is just a variable, and it's like a generic variable. Okay, so I will need a get counter function that will take a snapshot of the contract state. Okay, so get counter is going to be a view function. So it has to access the storage, but it doesn't have to modify it. So using get counter is just gonna like view what's on the blockchain without modifying it. So it's not gonna cost any gas. It's not gonna do any transaction. It's just gonna retrieve, fetch the data without interacting with it. So because of that, we are not taking a reference of the contract state, but just a snapshot. So that's like a very, it's a very subtle difference, but basically if you need to interact with the contract, you need to take it as a reference to be able to modify it. And if you only need to look at it, you don't. So here I don't, and this function when called is not gonna cost anything to the user.
Charlotte,
Yeah.
question from Ashok. Could you talk more about this pop keyword that we see before mod and before trade? What does it do?
It's just public. So it means that the traits and the module are public and can be used outside of this specific file. So if I remove it, it's not making any error because it's actually not used anywhere else. But if I want to use it anywhere else than in this specific file, I need to put public. And so here, if I don't have it public, I'm not sure I will even be able to use it here. Yeah, that's maybe for later. Yeah.
Yeah,
Yeah,
right
it's
now
just
it doesn't make much sense because it will apply when we talk about testing and we need to bring this code into scope. Because we're not doing
Yeah.
that now, it will be the same if it's public or private.
Yeah. Okay, so now I'm going to make a function that will increase the counter. So now, because we will modify the value, I need to take a reference of the contract state. So I will not use the snapshots. And yeah, that's it. No, yeah, that's it. Okay, then I will make decrease counter, also taking a ref of the contract state. And finally, I will make a reset counter. I will modify the storage value, so I need to take a reference of the contract state again. Okay, so here's our interface for the counter. I called him counter. It's like a naming convention. So it's interface of counter. And so it's defined over this generic type. So called contract state, because it's a generic type, but it's gonna be a contract state when we implement it. So it's better, like this could be anything, like I could be like, that would be valid, but it's better to add some information about what type of variable it could be, but basically it means it's a placeholder. And so now I'm gonna implement this interface inside my contract. So I'm gonna implement it here. So when, so this logic is code that will be used by externally. So in Cairo, there is this convention, like this syntax thing that you need to add this. So this is a bit weird, but it just means can be used externally. So just nothing crazy. Okay, and now I will implement counter implementation of counter of the contract state. And so I need to put into scope this. counter. So yeah, so basically now I'm putting this into this scope. So the interface, and I'm gonna implement it here. Okay, so the error now is that I need to implement get counter, increase counter, reset counter. So I will need to implement.
Charlotte,
this.
question from Favor. Can we write the trade without using T contract state within brackets? Angle brackets. Line 2.
This one?
Yeah.
Could you have a trait that doesn't have a generic? It wouldn't make sense. So the purpose of a trait is to define functions that have a generic variable, so that later on you can implement it with different possible variable values. So if you don't have that placeholder, like that variable, it doesn't make sense. Like you might as well just implement the function on themselves. Like if you're not gonna, if you're not gonna need this feature, it doesn't make sense. So yeah, I don't know what happens if you make a trait without this, like without any value like this, but it's probably going to throw an error because it's not the point of the trait. So
yeah, that is what's called an abstract type, and it's a way to make the trait more flexible, so you can use different concrete types when you actually use it. And I think one of the reasons is just because that specific type that you pass there is only generated at compile time thanks to the attributes that you see, like a Starknet contract. But yeah, it's a common pattern for traits just to make it more flexible.
Yeah. And also, like, traits are super useful if in like many different use cases. So for example, if you build like a math library and you want to make something like a function that computes different computation, but you want to compute them for all the possible types, for all the possible like unsigned, signed integer, floating point, fixed point, like any type of data, either primitive data or custom data that you create. It's very useful because you can have this very neat structure of all the function you need for all the type, and then you implement them separately. And it's like very clean code. And then when you use the different function that you created, you can use them in like a very neat way. So it's a very common and practical concept that can be used for many things. Yeah. Sorry, I went away. So now we will start implementing the counter. So here I have to change it to contract stage because now I'm implementing it on this specific type. Okay, so I need to get the counter. So self counter, this time I'm gonna need to read. Okay, I'm gonna have an error because I did not imported the capacity of reading. So I'm gonna import it now. So read access. Okay, perfect. No, I don't have an error anymore. Okay, so yeah, this is the very basic implementation of get counter. So it's taking a snapshot of the contract states. It's accessing the counter in the storage. It's reading it, and it's returning. I could add like return, but yeah, it's just working as well. Now I'm gonna do increase counter. Up. Okay, so again, I'm taking away the T because now we only do contract states. So this time I want to increase the counter. So first I will create old value. So in Cairo, a bit like in Rust, you need to use the word let before you initialize, like before you create a new variable. And then you can assign a value to it. And yeah. So
Question from Sanchez. What does ABI embed v0 do? Does it define the implemented functions to be part of ABI of the contract?
does it what?
Does it define the implemented functions to be part of the ABI of the contract? The ABI embed v0 attribute.
Yeah, so like the ABI is the application binary interface. So basically your code, so your smart contract is gonna compile into bytecode and the bytecode will be on chain. But the ABI is sort of something that is not on chain, it's off chain, but it's interacting, like it's a way of understanding the code on chain. And so in the ABI, you need to know what can be done on chain. And so what is the internal function, they don't need to be in the ABI because they're not gonna interact with the on-chain bytecode, but the ABI can be viewed as like, yeah, like it's metadata of like how to use how to interact with the on-chain bytecode. So here, I don't know exactly like to like a low level thing what it does. It's a bit out of scope for basic smart contract, but yeah, basically the ABI is what's gonna interact with your on-chain bytecode and for example, the wallets or any code that will need to interact with the on-chain data. So it needs to know what function interacts with that bytecode and like their signature, their like what does the function do and everything.
Yeah, just to add to that, if you're going from Solidity, basically what you're saying here is that all the methods within this implementation are going to be part of the ABI that's going to be created. So other smart contracts are going to be able to call the get counter and the increase counter of this smart contract, right? Because the public interface within the blockchain.
Yeah. Okay. So I just want to do that. Okay. So now I'm creating this the new counter, and now I will write in the storage. Okay. Okay. So here we want to make an event. So now we increase the value, and I'm gonna introduce the concept of an event. So an event is a way of interacting with the outside world. So it's a way of yeah, like the smart contract, and it can emit, and so it can communicate with whatever needs to have the information of what's the value of the counter, what's the contract address that emits, that changed the counter, like anything that you want to be able to emit can be done into an event. So I will create it here. So events are defined like this. Well, Okay. So events are enum and are called events. And yeah. So in Cairo, an enum is an enumeration. So basically, it's a way of defining multiple possible variable so that these and only these variable can exist. So for example, here with this specific event enum, if I create two possible variable, there's only going to exist those two variables. So it's a way to restrict the possibilities, and it's also very clean. So you know like what possibilities exist, and you know it's only this and nothing else. So here I will create increase. Okay.
There's a question for you, Charlotte, from Rockib. Can you explain the derive keyword and what drop does?
Okay. Yeah. So I'm going to do this so I remove the crazy errors. So basically, derive is a way to add a functionality to whatever is going to be underneath. So with this derive, I'm adding, like I'm giving superpower to this event enum basically. So I'm adding some functionality and some code under the hood. So it's a way to not have to code everything yourself and just reuse logic that needs to be used for that are like very generic. So a lot of enum needs to have this functionality, so it's easier to use derive, so it can be done very, very easily, and you don't have to do everything all the time. So the drop one is actually just gonna drop the event when it goes out of scope. So basically, if you use a primitive type, it's gonna do it for you. But if you create your own custom type, you need to tell the compiler what it needs to do when your a variable will be out of scope. And so here you just tell the compiler to drop it.
Yeah, just to add to that, drop is a trait, and derive is used to implement that trait in this case the enum of event. So the compiler knows how to remove out of memory this enum whenever it's not used anymore.
Yeah. So now I need to create the increased events. So I need to specify that it's an event and increase an event. So here it's a structure, so that we can give it all the field that we need. So in this one, we will emit the account that increased the amount. So you can emit whatever you want. Like you could emit the amount. You can emit the account. Here I'm gonna do the account. So I'm gonna emit the contract address. That's increase the counter. So for that, I need to use the Starknet contract address. Okay. And okay. So now here I can emit my events. So I'm gonna emit increased accounts Okay. So here I want to emit the account that has increased the counter. So to know who is increasing the counter, we need to know who is calling this function. And so actually we can retrieve this information by using getCallerAddress. So it's a function that exists that needs to be added in the scope. And that will no, not what am I doing wrong here? Okay, so
It's
when
self.emit.
yeah. Okay, perfect. Thank you. Okay. So now that's it. We have our increase counter. We will continue now on to decrease counter. So same but different. Now we will need to take the reference of the contract states. So first we take the old value. We can check that it's, so let's say we don't want the counter to be negative. In this case, we don't, because it's an unsigned integer, so it actually cannot be negative. So we're gonna add a start here and assert old value greater than 1. And okay. And we can throw an error. So either we do this, but it's not very, I mean, it's going to be a little bit annoying because if it fails, it's going to do something, like it's going to panic, but it's not going to tell you much. So we can create an error. So the error will, it's like a cleaner way of handling error instead of just either panicking or panicking with a message. If you create an error, you can actually know, like it's like you kind of acknowledge what possible error can happen, and it's much better practice, because you acknowledge what can go wrong, and it's here, and you make this enum, so like you acknowledge that only this can go wrong, and yeah, so it's very neat. So here I will make it's going to be a constant, and it's going to be called empty, no, I will call it so it's best practice to try to find a name that summarizes what is going wrong without too much phrase.
Hi, Charlotte. Maybe you should name this mod.
In what?
Instead of an enum. A mod. Instead of an enum.
It's a mod. Okay, yeah. Okay. Yeah, I thought it was an enum, but okay, yeah. empty counter. Okay. Empty.
Yeah, you have to annotate it as a felt 252, so it knows. It must be of
Sorry,
type felt 252. The const, the empty counter, yeah, felt 252. A felt must be a felt, yeah.
Yeah. Okay. Yeah. Yeah, because a constant needs to have a type, a sign. Okay, and then I can put it here. Okay. Can
You have to define the module. So it's error, colon, colon, empty counter.
Oh yeah. Sorry. String.
I think, Charlotte, you have a question. So some people are asking, is there any chance you can encounter integer overflow or underflow? And then Hitrick something is asking, what is felt 252? I think Favor is also asking the same question. Please can felt 252 be explained? So maybe you want to go over that.
Okay. So a felt is actually it's actually a very an interesting concept in Cairo, because like Cairo is so it's a language that is actually under the hood. It's doing some very complicated ZK things for you. So it's abstracting the ZK, but the mathematics that is underneath is actually field element mathematics. And so a felt is a number in the field element. So in like cryptography and like number theory and field element, and it's usually the field element is usually a very complicated number that has very nice properties. So usually it's a prime number. So it's not like 2 exponent 16 or something very like it's like a prime number. And so here it's actually the type felt 252. So in Cairo, that's a prime element. So that's actually like one case in memory. And when you code, it's anything, but it needs to be represented in max 31 bytes, because it's bounded by 31 characters. So it's a bit of an odd, unusual data type in computer language, in computer science. But yeah, basically that's like a field element in the field arithmetics that's going to happen when the Cairo code will be like proven and verified. Like all of it will be translated in felt elements, and so you can decide to use the felt elements. But yeah, like the compiler will actually at some point turn everything into a felt to be able to perform the arithmetics, the field element arithmetics on it. What was the other question?
I think that was it.
Well,
Sorry, David, go ahead. What's another question?
oh yeah, no, all the questions were the same. So they were kind of like asking about felt 252, and she has answered that. So good.
I think what's missing here, Charlotte, is that you have to make public the constant itself within the module.
Oh. Yeah. Why is it? Do I need it to be this? It's very strange. I still have. Okay, I'm actually. So when you have an error and you cannot figure it out, you need to go in the Cairo book. So let's do this process.
I know what it is.
You know what it
You're
is?
you're using assert instead of the macro assert. So if you remove the exclamation mark, it's just because the assert expects a short
Yeah.
string. The macro expects an actual byte string. So you can use either one, but just modify the type for the message.
Yeah, true. Okay, thank you. Okay, so let's continue with that. Now we decreased the counter. We want to do an event here again. So I will create now a decreased events. So basically it's gonna be the same, but it's gonna be called decreased. Okay. So nothing very new here. Just okay. So here I added a new event. It's following the same logic as the increase one, and I emit it in the same way. Oops, I forgot to I forgot to actually decrease it. So okay, so now that we asserted that the value is bigger than is greater than 0, we can change the value. Okay, and then we emit. Okay, so here I go back to the self, I go to the counter, I write in the counter previous value -1, and then I emit it here. Okay, so now we have one left function to code reset counter. Okay, so now we have to again take it by reference and then change the value. So we actually gonna introduce something new here, because I'm gonna decide that only one person can reset the counter. So no, like anyone cannot reset the counter, but only the person who created the contract. So basically, the logic will be to reset the counter to write 0 in the counter in the storage, but I want to add only owner can reset. Okay, so for that I will introduce something new. It's the components. So components are extra logic that you can add, that you can reuse from other projects, other packages, other contracts that like outside of your code. So it's actually very nice because you can use you can use components to reuse logic that exists. So for example, if you want to interact with like an ERC20 token, you don't want to create all the ERC token logic from scratch. So you reuse the components logic from it. So it's very nice because you can use component logic from projects that have been audited. So you don't need to audit it yourself, or you can audit it yourself, but you have this extra security knowing that it has been audited before. You can also like not do like recreate the wheel every time. So yeah, it's very useful. So here to do this, I'm gonna show you the so the Cairo package registry of scabs. So here we will use OpenZeppelin access. So basically it's how an access control created by OpenZeppelin. Okay, so to do it, you need to go to your scab. It's already here. Okay, I already. Okay, it's already here. So yeah, basically you need to put the dependency here. So you have a lot of, I mean, you have some possibilities that exist in like the Starknet standard. I guess we can call this like Starknet standard library. But you can also import packages. And here we are basically importing this component logic as an outside packages. Okay. So here we actually have an example of how to use this. So I'm gonna go ahead and copy this. I'm gonna rewrite it. So OpenZeppelin access, ownable, okay, ownable components. Okay, so now I have this that is in scope. We can actually go in the docs, and I'm going to show you. So this is the source code of this ownable component that I'm going to use. So I'm going to introduce component a bit more here so that you understand what is a component a bit better, and also how to make your own components if needed. So most of the time, I guess you will have to use components from other projects, especially as you begin. But maybe later on, you will also have to create your own components so that you can structure your smart contracts and separate some of the logic, or if you have logic that needs to be used in multiple smart contracts, or yeah, any sort of possibilities, components are very, very useful. So basically a component is kind of a smart contract, but it's not completely a smart contract. So for example, it cannot be deployed, but it has a lot of the same features. So it has a storage, it has, it can have events. It also has an interface. So here, the interface, so you don't need to code this. So I'm being a bit more fast, but let me know if you have any questions. So here the interface is defined here. So it's very similar to the smart contracts, but it's not a smart contract. It's not going to be deployed. It's just a piece of the logic. So here we can actually check the interface. So you have the owner that returns the contract address of the owner, transfer ownership that's taking the states, and the new owner, and that's gonna modify the ownership, and then renounce ownership, that's just gonna cancel the ownership and probably set it to 0 or something. Okay. So here I'm going back to the example of how to use the ownable components. So here I can see there's a component macro, as well as this like ownable mixing implementation. So basically, when you do a component, you need to, like when you use a component, you need to first put the components into scope, and then you need to declare it using the components macro. So here you can see there is a path, there's a storage, and there's an event. So you declare, it's a way to declare it. And then you need to add in the storage of the contract, the storage of the components, and in the events, you need to add the event of the components. And then you need to add the logic of the components. Components are can be seen as so Lego bricks, so additional logic that can be used and reused or imported from different projects or packages and can be used inside of your contracts. So it's a way to make your code cleaner, to reuse logic that's going to be needed in multiple smart contracts, or also using logic from trusted sources that has been audited, or so that's very good practice. So a component is a smart contract, but it's like annotated with the component attributes, and it cannot be deployed. So yeah, that's the main feature of it. And so to use it in your own code, you need to follow a little bit of steps, because you need to import the components, you need to declare it in the scope, and then you need to implement the traits that you want to use with your own contract state, for example. And then you need to add the storage and the events in your contract. So there is a few places where you need to put your components, and also you need to tell the ABI. You need to put the what needs to be interact with the external. What needs to be externally available needs to be set in the ABI as well. So let's do this. So basically here I'm gonna do exactly this one. So components macro path. So here I'm putting the component into the scope. So the path is this ownable component. Then the event is the storage first, storage, ownable, and then events. Ownable events. Okay. Okay, so I'm gonna now add in the storage this. So I called it here ownable, and I need to set it in my storage. So I'm gonna add the ownable component, the ownable components in the storage. It's okay. I also need to add this attributes. So it's an attribute that tells the compiler that it's the storage of the components. I don't know what this function. Okay, and then so now in the events I will add so I add the flat so that it's just a way to optimize the fact that it's using a complex structure. So I called it ownable events up. So ownable events.
Yeah, what I get in the comments is that you're missing a second semicolon. If you go up.
Yes, but I think
Oh, no, it's fine. It's fine. Sorry.
Ownable. No, this one. Okay. Perfect. Okay, so now we have the storage. We can actually check it here. So here is the code that I showed you on GitHub. So here we have the storage of the ownable components. It has the contract address of the owner and the possibility to have a pending owner as well. And here we can go check the events. So ownership transfer and ownership transfer started. Okay. So let's now implement the logic. So to implement the logic, as we saw, we need to tell the compiler that it's going to be added in the ABI. And then we have to implement. So we will implement one specific trait in the ownable components. We will implement the mixing. So basically here we're going to go in the components and maybe we can even go in the ownable. Okay. So we are going to implement this one. So basically it's an interface that I mean it's implementing this interface. So there is a owner function that returns the contract address, transfer ownership that returns that takes the contract state and then the new contract address of the new owner, and then it's gonna set in the storage this new owner as the owner, and then renounce ownership. For interoperability with different languages, you have it here in snake case for like Cairo, Rust, and here for like JavaScript, TypeScript. But yeah, basically this is just for developer to be able to use the function in a way that they are used to. So don't mind it too much, but that's gonna do the same thing. It's just so that no one is confused, I guess.
Charlotte, question
yeah.
from Ashok. Can all the functions accessible inside the contract that are defined inside the components?
Can all the function?
I guess the question, do you have access to all the functions defined in the component in your smart contract?
So as in, could you put everything in a component, or for a given component, you have everything? I guess.
Maybe, Ashok, if you can clarify, but I understood the question is that when you bring the component, do you bring all the functions along with it, or do you have to do something else to bring specific methods from the component to your smart contract?
I mean, here I'm just gonna implement some of the, so I can, I'm gonna show you it here. So in this component, there is different traits, and I'm just gonna implement this one. So you don't have to implement, like if a component is very big and is defined in multiple different traits, you can choose to only define one. But if it only has like one trait, it's gonna implement everything for you, and you cannot cherry pick a function that you want to implement. Like this would come as a package, but here I'm not gonna implement all of the different traits. But then you can also make your custom components if you want to only have some of the functionality, but usually they all make sense or are needed in a way. Like in this case, they all make sense.
Yeah, I think as long as the trait is public, you will be able to bring it over and use it in your contract, right? So it's all available if you want, but probably you want to use it, all of them.
Okay, so implement ownable scene implementation of ownable components, ownable mix. No, was it mixing? Oh, yes, same. Of contract state. Okay, so here what I'm doing is that I'm oh. I don't know what's wrong. Okay, yeah. So yeah, so here the implementation is a generic implementation of contract states, and now I'm bringing it in the scope, and I'm setting this as the variable was generic, and I set it to this one, and then we will implement ownable to step implementation. Ownable components. Okay. Contracts. Yeah, so here we're also gonna implement this one. So here they Which one is it? Is it? So it's okay. So basically, this one is a two-step ownable. So it's similar, but in the implementation, you can see that there is a little bit more subtlety. So you have a pending owner. So the first one is just you change the owner in one step, and this one is you you first make a request, then the request is pending and then accepted. So it's just a different processes for the ownership transfer, but basically you can it's code, so you can do it the way you want, and you can think of all that could go wrong with any implementation and try to make it more robust and secure. And this two-step has probably more robustness to different sort of attacks. So yeah, that's more like smart contract security here. But yeah, so when you code a smart contract, you always have this part of what can go wrong, how can you make sure nothing wrong can happen, and how can you make sure that that your smart contracts cannot be attacked. And that's also why people do how is it called audits to make sure that everything is safe. So here we have two different ways, the classic one and the two steps. And now we will use them in our contract. So let's go back to reset counter. So the point of all of this was to be able to make sure that the owner is that only the owner can change the can reset the counter, so that we add a little bit more security to our contract. So here I will do it here, so we can no donuts. Okay. So yeah, so here we can go back to the documentation of OpenZapping, and we can see that to assert is the owner. We can access ownable and then use the function assert on the owner. So we're gonna do it here. So ownable assert on the owner, and then we write in the contract. Okay. So yes, I think we are done with the implementation of the smart contract. Let me think, is there anything else I wanted to add? I think we covered everything and implemented everything. So now we have the smart contract. We can have a little summary here of what it's doing. So you can get the value of the counter, you can increase it, you can decrease it, you can reset it, but only the owner can reset it. So here you have the storage. So now in the storage, we have the counter, but we also have this additional storage needed to store the contract address of the owner. Then you have the constructor. Oh, I think I need to initialize. I think I need to initialize the
owner. Yeah.
Owner in the constructor.
Yes, that's a good call. You will want to do that.
Yes. So maybe it's here. Okay, perfect. So yeah, here self-ownable initializer owner. Okay. And then I will need to have owner here as a contract address. Okay. Okay. So now we have a constructor. When we deploy the smart contract, it's gonna run. It's only gonna run once. It's gonna initialize in the storage the initial value, and then the owner is gonna be this contract address. Now we have the events that's gonna be emitted when it's increased, when it's decreased. It's gonna emit the contract address of the color of the increased function and the decreased function, and it's gonna it's also use the events of the ownable components, which are emitting the change in the ownership. Okay, and then here we have the logic that was implemented. So all of the function mentioned were implemented here. Okay, so now we have this full smart contract situation, so we can start deploying it. So first I'm gonna build to make sure everything compiles and everything is okay. Perfect. Okay, so now I will use a yarn with the command chain that's gonna run a node here. And okay, and then I'm gonna do yarn deploy. To deploy the smart contracts. So because we initialize this project with Scalpel Stark when we did the deployment, there's a lot of things that are done for you. And yeah, so now we have the contract was deployed. So perfect. And now I'm gonna yarn start. Oops. And yes. Okay, so now we can have a first view of the smart contracts. Now, so here we can check the read and the write methods. So we have transfer ownership and renounce ownership from, but do you know why we have this, David?
Pierre? Okay. Sorry, it was frozen for me a bit, the image. Thought I lost you.
What do you mean, Charles?
I have the correct method, but not quite. Okay.
Which one are you looking for?
Like increase, decrease.
Oh, okay. Did you did the deploy to DevNet?
Yeah.
And you maybe do the deployment again just in case. Okay, your contract, that's the address. Okay, let's go back. Copy that address just in case the deployment address. Contract deploy at.
Yeah.
Okay.
Because is it the same? It is the same. I mean, it
You
looks.
refresh your browser. Maybe go to configure contracts. That's weird. Your contract, that's the one. That's the name, right?
Yeah. I can do it on the
No, it'd be deployed to
DevNet.
local DevNet.
Yeah. It won't be there.
Yeah. Yeah, it's on DevNet.
So probably we want to take a look at the ABI of your front end to see if it's currently passing the address that you deployed on DevNet. It's possible it's not
Oh, wait, did
referencing
you change the name of the smart contract? It's not called your contract anymore, right?
It's not called, yeah.
Just for now, okay, that's why. You change the default name.
Yeah.
It's expected to be called your contract. That's what's happening.
Ah, okay.
So for now, just to verify that's working, just change the name to your contract to see if that will make it work. And
Okay.
deploy again.
Can you show again your library? The .cairo? Thanks.
Wait, you're getting this error only when you deploy? Like if you do yarn compile, it works?
Have you tried to build it first? Is it compiling?
Yeah, she just compiled it and
Okay,
it worked.
okay, sure, it's compiling, okay.
Look, if we're stuck right now, we're not gonna be able to debug it with the 50 minutes left, I think. I know you wanted to discuss something else, or you want to jump to like show Starklings?
Yeah, I can show Starklings.
Yeah, we'll do that.
Yeah. Okay. So yeah, so one of the homework is to complete the Starklings. So Starklings are exercises in Cairo. So it's like a web app that was created so that you can easily learn Cairo. So it's not necessarily focused on Cairo as a smart contract, like for smart contract application, but more learning Cairo as a programming language. So it's really nice. It's a bit a playful way to learn the language. And what I would recommend for you is to use the Cairo book as a resource to do the Starklings. So basically, when you're gonna complete the Starklings home, you will do a lot of back and forth between Starklings and the Cairo book, because the Cairo book is the official language, the official documentation of the Cairo language, and it's really well done. It's like you can read it as a book, and it explains all the programming concepts of Cairo. So it's actually done in two parts. You have the first part that is Cairo as a programming language. So it explains all the different programming aspects of it. So variable, data type, control flow, else, if, like all the syntax, the enum. So all of the things we covered actually are really well detailed. Like the syntax is explained, how things work in memory. Like it's really complete. And you also have a part that covers smart contract in Cairo. So when you want to go deeper, if you don't understand something, if you try to use like a certain macro, but you don't know how to use it, most of the time you're actually going to find it in the Cairo book. So it's very useful. Yeah, so here you have all about smart contracts. So storage, the ABI, you have the components, you also have testing, and yeah, it's very complete. It's very well put together. Great resource. So let's start with the Starklings. So I think you will have to complete like all the exercises for the end of the Basecamp. So I will start from scratch and actually go on Google and look for Starklings so that you can follow along. So you go on Starkling, that it's Starklings app. Yay, Basecamp. Then start coding. Maybe you have to connect your GitHub. Yeah, there's probably a step where you have to connect to your GitHub, and then you can start coding. So all of the exercises are done with a little bit of forward and explanation, and here you can code. So let's do the first one. It's an exercise that doesn't do anything, but it still compiles, because that's actually a correct Cairo code. So this is in Cairo, this is the minimum that is required for the code to compile and to be considered as a Cairo code. So basically, it's a main function. All code needs to have the main function. So fn is the keyword for function. Then you have the name of the function, brackets for possible arguments, and then the body of the function will be here. So it's perfect. It's not going to do anything. It's just going to work. And then we can go to the next one. Okay. So it's did a bit of a jump here because I actually did the, sorry about it. Okay. So now we have a blank code and it says the exercise won't compile. Can you make it compile? So basically it needs a main function. So yeah, we can put the main function, name of the function, no arguments. It doesn't return anything either. So if you want a return type, you would have to add it here, but whoops, here we don't want any return type. So we do it here, perfect. Now we can go to the second one. So variable, make me compile. So, okay, so I'm gonna do it in a, as in I didn't know anything about Cairo, so because that's how you will probably have to complete the exercises. So basically it's about variables. I don't know what's wrong, I can try. It's not working. So here you have the you have the error message. So you can start reading the error message. You can go in the Cairo book. You can go in variable, have a little read to try to understand what's happening. So it uses immutable memory model. Once a memory cell is written, it cannot be overwritten, but only read from to reflect the immutable memory model. Cairo are variables are immutable by default, or you can make the variable mutable by enforcing it. So yeah, so this is like a full explanation of the memory model of Cairo, of how the variables are used. So basically, when you create a new variable, it's immutable by default. If you want to make it mutable, you have to add the mute keyword. And here you have a mutable variable and you can change the value. Okay. So now that we have this new information, we can go back to the code. Okay. We can see that was actually I've been a bit too fast. It wasn't about the mutability, sorry. So here we can see that the error is identifier not found, invalid left-hand side of the assignment. So we can see that here in this function, you have the keyword let. So when you create a new variable in Cairo, you have to declare it. So you have to tell the compiler, I'm going to declare a new variable. You cannot just use it like that. So here, identifier not found. So the compiler doesn't know what XS is, and we didn't tell him that we were going to create a new variable. So we need to use the word let to initialize the variable X, and now it's going to compile. So yeah, so for the rest of it, you guys will have to do it on your own. So yeah, I strongly recommend you to really read the chapter about each of the concepts before trying to do the exercises. It's going to be much more easy if you read this whole text before trying to do the exercise. The exercise is going to be super easy to do. So good luck with the Starklings and good luck with the rest of the Basecamp.